let's start talking about the efficiency transfer things. When I downloaded this software from net, it's freely available. I found out that there is a version for Genie 2, which is practically the same version as this one, which I use here. I think that the only difference is that this system can give information to Genie or get information back to Genie. I don't know exactly. All right, this is a user interface is more like same as in ASIS software, so it's very, very, very easy. So there are only 3 windows: detector window, source window, and finally the efficiency window. Let's look at the detector window. Detector is described here. So there is a bulletization, or might be bulletization. There might be absorber at top of the detector. This is detector window here. There's a gap between the detector and the window. Housing is the thing that you see when you look at the spectrometer, etc. But let's go here. So the only thing that you need to put for detector information is this. And if you change this information, you can store the information. For example, in this case, the crystal diameter is assumed to be 8 centimeters and thickness 3 centimeters. There is no bulletization, dead layer thickness, side layer thickness, etc., etc. So these are very simple input values. Once you do it, it's that. You do not need to change it.
But do we get these values?
Sorry?
Do we get the values of dead layers and side dead layer?
Well, to get values for the dead layer, it's very difficult because usually the Mirion or Ortec doesn't give you that information. But I said to them, when I last time bought my detector, that, okay, I will not buy your detector if you don't give me this information. Because the price of the detector is, in Finland, 100,000 euros, very expensive. So they gave me this information, but they said that, Roy, please don't give this information to other, don't publish it. I don't know the correct level of dead layer in this case because this is probably not one of our detectors. But this is just an example. Dead layer is typically very thin, some micrometers only. Okay, let's go to the source. Now there are 2 sources, which is standard here, and the sample itself. Now remember, this is our standard, this one. As I told you, this is so-called T20 calibration. So I don't remember exact diameter of our sample, but it is around 5 centimeters or 7 centimeters. I put there container diameter 5 centimeters. And container bottom thickness is 1 millimeter, as just an example. I have there water or almost water. There is some acid there. And 2 centimeters is the filling height. Very easy, very easy. Now, about the sample we are measuring. What about if we are measuring water sample, but thickness 1 centimeter? Everything is same here. Let's look at the efficiency curve. This is some efficiency curve. These are the efficiency values here. This is the energy. You can put uncertainty there. And please, this is Excel. You can change the axis as normal Excel. Okay, let's do the calculation. I hope it works. No. Why it's not working?
Standard efficiency is 0.12. Sample efficiency is 0.15.
This is not the sample efficiency, this is the standard efficiency. Okay. But why can't I see it? I don't understand, sorry.
It's giving the values.
Yes, it gives the values, but I want to see the values here.
It's below. It should be in charge.
Can you? I don't. Because when I click here, it should show the value. Okay, I will start it again. Efficiency transfer. Okay. Now I change only these things. 20 millimeters. Let's put here 50 millimeter diameter, 1 millimeter thickness of wall bottom. Let's assume water. Sorry. This one. Now the sample. 10 millimeters. Exactly the same beaker. 1, 1. Okay, now it's okay. Now I think it should operate. All right, now it's this one. I select change logarithmic axis here, so it's this. Let's put the minimum value 10 kilo electron volts. So, if the sample is...
How you got these values?
Well, this black is the, how to say, it's the standard value that I very carefully have been done. So this is efficiency transfer if I use a sample with 1 centimeter thick. We can very easily change values here. Let's assume that the sample thickness is only 1 millimeter. Do efficiency calculation again. It's like this, in this case. Normally, what I do is to put efficiency values as 1, because it's more easy to check relative values. All right, now this is the efficiency, this black curve here. And let's change, for example, this number to be 3 centimeter thick. Calculate it again. Now it's easy to see what happens. all efficiencies are 1.
Two different matrices. One is water.
Sorry, I have to go close because of... Yeah.
So if I want to use two matrices, now you have used water in both the cases.
Yeah.
For example, I want to use water for standard,
Yeah.
understand, and for the sample I use sand.
Something kind. Yeah, all right. Let's see. I will change the number format here. Sorry. Number. Excel is sometimes quite number. Now it's more easy to see. Okay, let's change. Let's put the same source height, but now it's not water, but something else. Let's assume that it is. I have done new materials here. Let's assume that it is sand, but now in this case, density is 1. This can be easily changed. But let happens. Let's see what happens. Very easy. Very easy. Now you doesn't anymore do any standard measurements. You just do this calculation. There is a Gini version.
Can I select the density of the material?
Yes, but not in this interface. I think that this interface is a little bit clumsy because I can't select the density here. The material properties are, in fact, got from NIST-made so-called XCOM program. So it belongs to this Efftran package, and there you can do different materials. But you have to know something about your material composition. We can change it very easily. Let's try this suolavesi. It's salted water, like seawater. It has salt. Let's do again calculation. Effect is this. If I assume that thickness is 2 millimeters, do calculation again. New resolution is this one. So, very simple system. But I suggest you to download this Efftran software and do it yourselves, because it's a way to understand what happens. If you have a different beaker size, for example, if you do not want to use same kind of beakers as you normally do, it's easy to change. For example, container diameter. If it is, let's put it 70 millimeters, and do the calculation again. The result is this. Very easy. Do you want to see other calculations? Please give me suggestions.
How to download this software?
I gave Karunakara the website.
So
Yeah. Do you want to have more calculations? for example, let's assume that we have exactly the same source filling height. Let's assume it's also water, but the beaker bottom thickness is very thick, 5 millimeters instead of 1 millimeter. Sorry, can you
please show one sample for air filter?
one
One sample for air filter. Filter sample.
air filter? So
Yeah. Okay. No, I tell you there's no problem.
So, in case of air filters, we can do this software. So the point is that source filling height, in that case, its filter thickness is very small. It's, let's say it's one millimeter thick. Let's assume that. All right. And if we are measuring it in the same container as in the case of standard sample. But the material is not water, filter material is not water. Let's see, is there any appropriate materials? Silica. Glass. Please know that one thing is very important if you are doing gamma spectrometry in case of low energy gammas. Then elemental composition, what are the elements, are of importance. You should know something about the composition. At higher energies, the composition is not relevant. Higher means more than 100 kiloelectronvolts. But let's say, for example, at the energies of lead 210, then elemental composition is practically necessary. You have to know something, but you can easily assume that all plants, for example, have same composition. But the composition is of course different if you're measuring soil samples. The composition may vary. Is it organic soil or inorganic soil? I mean sand. That's the only, how to say, difficulty here. But it is only for low energies. Very handy system. I have learned a lot of using this system. And you can easily transfer this data to Excel. Just Control-C and add. Now you can print the pictures here. The problem here is that it only shows one efficiency per time. I don't like this, but I can do it like this and print data here. All right, this is it.